Hi everyone, so now we're going to be talking about absolute value inequalities. And absolute value inequalities are essentially compound inequalities, they just look slightly different or a little bit different. So let's just kind of go over the different options that we have. So this is going to get a little bit confusing, but on the left side of my screen I have the absolute value of x is less than some number. So when you have an absolute value is less than some number or less than or equal to some number, it's considered an and inequality or an and compound inequality. And so what's going to happen is that you're going to end up with some answer that looks like this, where you have the negative version of the number is less than x is less than a number. And then if you have the absolute value is greater than some number, then it's an or inequality, and you end up with some answer like this where you have x is less than the negative version of that number or x is greater than that number. It's easiest, I believe, to kind of show you just with examples. So let's start with the first example. The first example says the absolute value of m is less than or equal to 4. So the first thing I'm going to do is look and decide if it's an and or an or inequality. Because it's less than or equal to, but when it's that less than, that tells me it's an and inequality. So we're going to kind of follow the left side of my screen. And this combines the absolute value rules with the inequality rules. So if you remember in my absolute value video, we had to, when you have an absolute value, you have two equations. You have one equation that is as if you just took the absolute values away, and then you have another equation where you take the absolute values away, but then to put a negative on the number. So I'm going to do that right now. I'm going to just have one inequality where I just take the absolute values away. So I have m is less than 4, and then with the other inequality, what I'm going to do is say m and then negative 4. But when I switch that to negative, I also have to switch the inequality sign so it becomes greater than or equal to 4. So those are my two solutions, and I know that there's this and in between them. Now, if you remember in my last video, we kind of smashed the two inequalities together when it's an and inequality. So I can still do that, but what I'm going to do is change this left inequality so that it's 4 is greater than or equal to m. That says the exact same thing as what's above it. It's just that I flip-flopped everything. And then I can rewrite this one so m is greater than or equal to negative 4. And then what I can do is actually smash those m's together and say 4 is greater than or equal to m, which is also greater than or equal to negative 4. Now, this is totally right, and we could leave it like this, but I'm going to flip everything around because we're used to reading it the other way, where it's like a less than or equal to and less than or equal to. So I'm going to say negative 4 is less than or equal to m is less than or equal to 4. Once again, that says exactly the same thing as what it says on top. It just shows that it's just a different way of writing it. And so, once again, we can graph that on a number line the same way that we were graphing in that last video. So I find negative 4, I find 4, because it's less than or equal to, I'm going to put solid dots, and then I can connect the dots. Okay, cool. So now let's try an or inequality. So the second example, and I'm going to set it right here just so we can kind of see these other notes above, is the absolute value of negative 5 plus n is greater than or equal to 11. Okay, so once again, we're going to write our two equations. We know because it's a greater than sign, it's an or. So I'm just going to write or right there so I can remind myself. So now I'm going to write my two equations. So I'm going to say negative 5 plus n is greater than or equal to 11. And then or negative 5 plus n is less than or equal to negative 11. Remember, when we switch the sign on the answer portion, we also switch the inequality. So now I can solve both of those equations by adding 5 to each side. I would get n and then 16, and then n is greater than or equal to 16. I'm going to add 5 to each side here, get n right there, less than or equal to negative 6. So I have n is greater than or equal to 16, and then n is less than or equal to negative 6. I have an or in between them because it is an or inequality. So those are my answers. Let's graph those. So we have negative 6, and then up here we'd have 16. So it has to be n is greater than 16, greater than or equal to 16, so it's a solid dot, and it's going to point this way because it's greater than or equal to 16. That means that it has to be bigger than 16, which means the arrow points towards the right. Then we have n is less than or equal to negative 6. That means there's a solid dot at negative 6, and then the arrow points towards the left. And there's our graph. Okay, so now let's go through the last two examples. So the third example is 5 plus the absolute value of b minus 2 is less than 1. So the first step in normal absolute value equations is to get the absolute value by itself. You have to get the absolute value by itself on one side before you can even write your two equations. So in order to do that in this case, what we'd have to do is move that 5. Right now the 5 is adding to the absolute value, so we're going to subtract 5 from each side. And we end up with the absolute value of b minus 2 is less than 1 minus 5 gives me negative 4. Now, if you remember, absolute values in the equations had a really important rule that said that you cannot have an absolute value equal to a negative number. It is also the case in inequalities. So we can't have an absolute value that's less than or greater than a negative number. It just doesn't make sense because absolute values are always positive, and so if they're even if they're less than a negative or greater than a negative number, still doesn't make sense. And so automatically I can just tell you that my answer is no solutions in this case because of this negative 4. We cannot have an absolute value already automatically set equal to a negative number. So when we graph a no solutions answer, it would just not be a graph. You just wouldn't even graph anything. Okay, and then number 4, or the last example, is 10 plus 2 times the absolute value of x minus 3 is less than 14. So in this case, once again, we're going to get rid of everything on the outside of the absolute values first. We're going to get rid of the 10 first by subtracting it. So now I just have 2 times the absolute value of x minus 3 is less than 4. Now I still want to get rid of the 2 that's in front of the absolute values. It's multiplying, so we're going to get rid of it by dividing by 2. The 2's cancel out, and I'm just left with the absolute value of x minus 3 is less than 2. Okay, so we know based on these rules that that less than sign means that it's an and inequality. So I'm going to write my two equations. I'm going to say x minus 3 is less than 2 and x minus 3 is greater than negative 2. Okay, so now we just have to solve both of those. I'm going to solve them by adding 3 to each side to get the x by itself. I'd get x is less than 5 on this side, and then I'm going to add 3 on this side, and I would get x is greater than negative 2 plus 3 gives me a 1. So once again, I can say it's x is less than 5 and x is greater than 1. If I want to smash them together, I would flip-flop the first one so it says 5 is greater than x, and then x is greater than 1. I can smash those two x's together so it says 5 is greater than x, which is greater than 1. But because we want to read it with less than signs, we would just say 1 is less than x is less than 5. So this is my official answer, while all of those other options are totally cool too. And when we graph them, we have 1, we have 5. Because they're just less thans, they're open dots, and then we connect the two dots. And there we have it, how to graph absolute value compound